Okay, welcome back. In this video we're going to be looking at sketching the graph of a straight line. So essentially, in order to sketch a graph, or in order to sketch a line, all we really need is 2 points, because as soon as we have 2 points we can rule a line through them. And the easiest 2 points to find are the y-intercept and the x-intercept. And once we've found those, rule a line between them. So, the first thing that you need to do is, whatever form you're given the equation in, you need to transpose it into this form. So we've just got y, making y the subject, equals mx plus c. So this, remember, m is the gradient. So remember, if we've got a positive gradient, it's going to be heading up as we go in the x direction. If we've got a negative gradient, the line is going to be going down. Could be really steep, it could be quite shallow, but if it's negative, it's going to be going down as we move up in the x direction. This value here, the c at the end, is going to tell us the y-intercept. And the y-intercept, essentially, it's along this line. So the x value that corresponds to the y-intercept is when x equals 0. So at x equals, at the 0 point on the x-axis, we're talking about where the line hits the y-axis. So regardless of what the slope is, if we plug 0 in for x, it's going to make that into 0, and we end up with this. So if I just write that down, the y-intercept is when x equals 0. And that's a clue to helping us find out. So essentially, our first point is, once you've got it in this form, is going to be 0, comma, whatever this c is. Let's write it in red. So somewhere on this, on the y-axis, it's going to be this value, whether it be positive or negative, and that corresponds to when x equals 0. Our second point, it's easiest to find the x-intercept, and that happens when y equals 0. So the y-intercept, I'm using that as abbreviation, is when y equals 0. So that essentially means, once we've got this bit, we're going to substitute y equals 0 over here, and then we need to do a little bit of rearranging. So maybe we'll do a bit of transposing on this. So if we let y equals 0, we say 0 equals mx plus c. Don't forget, this c could be negative. So 0, if we want to rearrange to find out what this x value is when y equals 0, we'll take c away from both sides. So we end up with negative c equals mx, and then we'll divide both sides by the gradient, so that cancels. So really, our x-intercept happens at negative c on m, comma 0. It's a bit of a convoluted way of thinking about it, but hopefully when we get some numbers in here, that will make a bit more sense. So something to remember, I sort of already mentioned, when this is positive, we're going to have a graph going up. When this is negative, we're going to have a graph going down, and this number should tell us where it cuts the y-intercept. But we're going to just jump straight into these examples, and hopefully once we have a bit of practice, it will start clicking into place. So this is the 2.5. So our first one, we'll do these one at a time. Y equals 2x plus 5. So straight away, it's in the right form. So I'm going to say that the y-intercept at, and I'm going to write it as a coordinate, 0, 5. So straight from just looking at the equation, I've already got 1 point. When we plug 0 in here, 0 times 2 is 0, plus 5. So then, because this is positive, I know it's going upwards. Every one step, it goes up 2. So what I'm going to do is to find the x-intercept. So we're going to let y equal 0. So substitute 0 equals 2x plus 5. I'm going to rearrange now. So that cancels with that. We get negative 5 equals 2x. And then divide both sides by 2. So that cancels with that. So our x-intercept at, so negative 5 divided by 2, let's call that negative 2.5, comma 0. So now that we've got 2 points, we can put them on our line. So when we're sketching the graph of a line, all we really need to do is have the axes, we rule the line, and then we can mark in these 2 points. So because I know that 5 is twice as big as 2.5, I'm going to do it like that. It doesn't have to be accurate as long as you label those intercepts. So I'm going to call that point 5 and that negative 2.5. And just so that we remember what we're doing, I'm just going to label my graph y equals 2x plus 5. So every 2 steps you go in the x direction, every 1 step in the x direction it goes up 2, and it crosses the y axis at 5. So this is really the only maths we have to do, but always remembering the gradient will give us an indication of whether the line's going up, how steeply it's going up. This is going to be our y-intercept, and then we let y equal 0 and rearrange to find the x-intercept. Okay, we'll do the next one. So we've got a few of these. Right, so y equals negative x plus 8. So just looking at it, our gradient is negative 4. So every 1 step in the positive x direction, the line comes down 4. So we're going to have a line going in this direction. So if we just start our axes off, really I should have ruled that. Our y-intercept, when we plug in x equals 0, negative 4 times 0 is 0, is 8. So the y x-intercept at 0, 8. We know that already. So somewhere up here it's going to cross the y-intercept, and then the x-intercept when y equals 0. So we're just going to say 0 equals -4 x plus 8, and then rearrange to make x the subject to work out what value of x this line crosses the x-intercept, because that's where y equals 0 on the axis. Okay, so we're going to take away 8 from both sides. Take away 8, take away 8, and we get -8. That cancels, equals -4x. And then we'll divide both sides by this -4. So over here that cancels. -8 divided by -4 is going to give us +2. So the x-intercept, therefore x-intercept at 2, 0. So we've got, here's 1 point, 0, 8, and 2, 0 is our second point. So why don't we just, if we say that is 8, and that's 2, and we'll draw our line sketch, and I'll just label it y equals -4 x plus 8. So -4 is the slope, and it's coming down. It crosses the y-intercept at 8, and we worked out that it crosses the x-intercept at 2. So we've got a couple more of these, and then we've got a few sort of very basic graphs that we'll have a look at just to finish this little section off. Right, so get rid of that. So our next one is y equals -3x, take away 6. So straight away, it's not very straight, is it? But this is just a sketch. So I know that it's going to cross the y-intercept at -6, so it's going to, let's call that -6, and our slope is -3, so it's going to be coming down this way, but we just need to work out at what value over here on the x-axis the line is going to cross. So the y, let's just write y-intercept at 0, -6, simply because of this. We let this equal 0, -3x, take 6, so we'll rearrange to make x the subject. So first add 6, so we get 6 equals -3x, and then divide by -3. So that cancels with that, and we get x equals 6 divided by 3 is 2, and a positive divided by a negative, -2, so the x-intercept at -2, 0. So I'm just going to draw the line first. Let's do it like that, because if that's 6, we need something a whole lot smaller. And then once I've got that, I'll write -2 in there. If you put -2 in first and then rule the line, from seeing a lot of students' graph sketches in the past, they tend to manage to miss the point that they've worked out that the line should pass through. So if you just draw the line first and then as long as it's going in the right direction and it's got the right slope, so this means for every one step in the x direction, it's going to take us halfway, it goes down 3. So that is going to be -3. One more step, -6. Another step, -9. Okay, so we've got one more. And our equation is y equals 3x. So there's no number on the end, so that is kind of the same as saying plus nothing. So our y-intercept at 0, 0. And that should be a clue. If we just draw the axes. So if the line is passing through the y-intercept here, that point is also on our x-intercept, our x-axis, so that is also the x-intercept, but we'll just check. So if we let this y equal 0, then we divide both sides by 3, 0 divided by 3, x equals 0. So there is our x and y intercept. So in this case, in order to draw the line, we need to substitute another value for x in. And the easiest one, so to find another point, let's substitute x equals 1. So y equals 3, lots of 1, which equals 3. So another point on our line is 1, the one that we substituted in, comma 3. So if we sort of call that 1, then 3 is there, say. And so that gives us our second point with which we can draw the line. So that's a specific case where just simply where the y-intercept and the x-intercept happen to be in the same place. So we needed to substitute a different value of x in to find another point that we could rule the straight line through. I hope that makes sense. We could have chosen anything else. If we'd have chosen -1, 3 times -1 would have given us a point down here. If we'd have chosen x equals 2, it would have given us 6 up here. But as long as we stick with, as long as we do the maths right, it will still be a point on this y equals 3x line. So let's just label that. Okay. Hopefully that makes sense. Right, so the last little thing is the shaded area in the book, and it is essentially just a summary of the different, some sort of basic graphs. So our first one is y equals x. That's sort of the most basic line. Let's just write all these out first. Y equals ax. So on the example, it's like the one we just did. Y equals -ax. So let's say y equals -5x. So these are the sort of general forms these are just examples. Y equals B. And we'll fit the last one, X equals C. So this is, for example, Y equals 4 or X equals -2. Y, X, and then we'll squeeze this one in here. Y, X. Okay, so if this is essentially for every one step we go in the X direction, we go up 1 because the gradient is 1. So this is, let's do it in red. We'll do it in red. That's that line. So essentially, think of this as a 45-degree angle, and for every one step we come this direction, we go up 1. So that is the basic. If it was Y equals -X, it would come down this way. So this was the one we just graphed. Because we've got nothing on the end, it also passes through that point 0, 0, but because we've got a number, it's a lot steeper than this one. So that would be like that. Same with this one. It also, because we've got nothing being added on, it passes through that point that the axes cross. This one's negative, and it's even slopier downwards than that. So let's put it in like that. And that means so this one, every one step we come across, we go up 3. One across, up 3. But this one, for every one step we come across, we go down 5. One across, down 5. These ones, where we just have Y equals some number. I've already written B. That's the example in the book. So essentially, we've got a slope of 0 because we've got no x's, and we just have this number on the end. So the example is Y equals 4. That is essentially a horizontal line that passes through Y equals 4. For this example, what X equals some constant number. So here they've used X equals -2. This is essentially a vertical line because it doesn't matter. No value of Y is going to change the fact that X is going to be -2. So these horizontal lines where Y equals a number, doesn't matter what value the X is because we've got no X in our equation. And the same if we have no Y in the equation. It's just going to be a constant horizontal line. Probably won't come across these that often, but just in case, it's worth bearing in mind. Alright, that's where I'm going to leave this one. Hopefully that was enough examples to get sketching the graphs of lines. Enough examples. Right, so I'll see you in the next video.